All right. Let's see how this goes over here. I've got this pod here. So this is where it started. This is blue foam. It's been fiberglassed, auto primer, and then auto clear, 2K clear, and then sanded and buffed. So basically, it gets me to this point. And then from the plug, I made the mold. This is sort of dirty. I got to clean some PVA off of it. So anyway, you get the mold. And then from that, you start making parts. Now, these parts were made with just West Systems. Nothing fancy, but it's a good utility resin at room temp. And I got these two parts, left and right half, and what I've got to do is trim them, put some masking tape on them, and seam them. So I've got a seam from the front and the back, so this has got to be cut out here, because when these two parts are together, I got to be able to access the mold. The back half of this mold is going to be cut at an angle so I can actually run some seam tape down from the inside. Subsequent molds and maybe reworking this mold, what I want to do eventually is make these mold halves clamp together and have the front and the back open so I can vacuum bag through the mold, or I can join the halves in the mold. So I might probably lay this thing up with glass and bring the glass up over the mold on both sides of the mold. Put the mold halves together and then go down with a long brush or whatever and take the fiberglass that's overlapping and push it down, and that way I join the right and left half in the mold. And then of course if you vacuum bag, the way it'll happen is the front and the back have to be open so you can run the bag through it. So that's all future stuff. I just wanted to get one part out of the mold. I wasn't too worried about doing too much. This is just so I can get a part. Now this is probably a little bit heavier than I want, but to start out with for the first part, I'll be happy with it. So what I do, I take these scissors, they've got like carbon inserts, so I'm able to cut high carbon steel. So I'm able to actually cut this off. It's already been cured. So I just go through here and trim it. I get it within a 1/16 of an inch or maybe less. Then I'll go ahead and I'll go around here and sand it. I use like perma-grit. It cuts pretty easy. I'll tell you what, it'd be nice. I don't know where I could get them, but it'd be a pair of these scissors that are even 2 or 3 times this size with the same high carbon inserts. These things work great. Obviously I'm not going to do the whole thing, but then you just take perma-grit and then sand up to the line. The line's very distinct. What I like to do before I take the PVA off, I like to actually join the halves together. So if I've got epoxy on my hands and I get it all over the mold or the part, it doesn't really matter because it's on top of the PVA. And then when I put the mold halves together, if any of the, working it from the inside, the tape, if it oozes out, it's okay too, because it'll come back on top of the PVA, and when it comes time to clean the seam, it cleans up really good because of the epoxy being on the outside of the PVA. So that's about all I wanted to cover there. Nothing special. I'm going to get a whiteboard. I want to show you something on this bell crank deal. So this carbon fiber bell crank is something that I've been thinking about for a while. I think I finally come up to a decision to go with this route. And the way it's going to work, it's going to be a carbon bell crank with a fork in it. So it's going to look like this. So I'm going to lay up this profile on this sheet. Now this is a sheet of aluminum. It's been semi-polished. It's not mirror finish. But basically it's got this profile in it. So what you're looking at right here, if you can see it, if I can get closer, move in a little bit here. What you're looking at here, right here, is the profile of this aluminum. So this is your aluminum plate right here. That's this. This out here is a piece of plate glass. Goes out like this. So in effect, what you're going to do, you're going to vacuum bag, or I am, you're going to vacuum bag carbon fiber over the top of this form on the glass. And I'm not sure how many layers it's going to take. So once you vacuum bag this down, it'll take a little testing to come up with the right everything. You're going to pop this off, okay? So you're going to take this profile of the cured carbon, and it's going to be shaped like this, okay? It's going to go up. Across. So you're going to have a sheet of carbon that's shaped like this. I got to think about it because I'm doing this upside down. Okay, so when you vacuum bag this down, this part here will be the peel ply. You're going to have peel ply here. This will be it right here. And peel ply on the top, and this will be the carbon. To be determined on how thick and how many layers. So the peel ply will allow secondary bonding. So once you get all this stuff apart, you're going to cut the top and bottom out, and you're going to come over the top of it with another piece of this carbon. Okay, so basically you're going to put this bell crank together out of a sheet of carbon, but it's got to be cut out. When I was laying the bell cranks up, I'd do the old worn truss thing, okay? I'd take the mold, you know, it was like this. I'd have pins here, and I'd mold a bushing in it. I'd take the carbon, and I'd go around the mold, okay? And I'd wrap it back and forth. It took 20 minutes to lay up a bell crank. and then probably another 5 for flashing. And then I'd make the bushings and bush it all. That's another 15 because it was late time. So okay, let's say 40 minutes, 45 minutes, probably to an hour. Hour would be like the max. I couldn't scale that. Basically, it was one at a time and it took forever, but it gave me a product because it was 36 inches, you know, as it went around here. It was all continuous toe, okay? There's no other way to get continuous toe but hand lay it like I did. Okay, so then they came up with this thing where they were talking about a fork. The reason they want the fork is they're going to put a button in here. So this will be a shaft, and it could have C-clips on it here. It would have to be precision machined to C-clip it. It might be a permanent clip on one end and a C-clip on the other, or it could be a aircraft lock nut with a grade 8 bolt. I don't know. That's all to be determined. The idea between this versus this is there'll be a button in here, and the button basically will have a groove in it. The button is going to pivot on this post. So looking at it from the top view, your lead outs are going to come in, go around this button and terminate, but it's all going to be pivoting here. So you're not going around. The lead outs aren't pivoting on a sharp corner. It's pivoting on a button that's on this pin. And I hope this is somewhat viewable. Let me make sure. So yeah, here's the button and here's the pin. Okay, so that's an improvement. And it's scalable. So you job out the machining of the pin, the button, and if the prototype comes out okay on this, it'll go from a high temp cooked resin in a vacuum bag to a full-size mold that'll be autoclave. And the carbon that comes out of the autoclave will be, as far as the fabric goes, the consolidation will be optimal. So here's the thing. You send this off to be autoclaved in a big huge sheet. You pull it off and demold it, and then you actually take the sheets into a water jet. So what I've got to determine is, with this new method where there's not continuous toe, what shape is this bell crank going to be? Is it going to be one of these things where the bell crank is going to be a conventional like this, you know? What shape is this bell crank going to be? The reason why it was the Warren Truss, because that's where you got the most strength. With the actual button in it, you know, you're relying on all the plies, you know, at different orientations for the strength. So I'm going to just make this stuff here in-house, destruction test it, and see how far I can go with what weave in different configurations. When it's all finalized, I job the mold out. I job out the autoclave pre-preg for the molding of the bell crank material. I job out the water jet cut. The only thing I'll do is take the water jet cut pieces, which will be whatever. I'll join the two halves together. Within the two halves, I'll probably have some kind of a bushing that will go in the carbon. And that way, it'll have an oil light bushing, just like the original did. And the secondary bonding of the two halves, the putting together, you know, the button and the post and all that. So there won't be much left. It'll just be the final assembly of a few things. Now, you get rid of a lot of labor, but by doing that, you incur a lot of cost to do it. So I'm still in the stage where I'm going to go through here and see how far I can get with in-house, and then from there I'll make the decision, and I might alter this a little bit. The other beauty of this method is if you want to change the holes, okay, all you do is tell the water jet cutter that, okay, we don't want 9/10, or we want 9/10 and we want 3/4 or whatever. It's all a couple mouse clicks. Once you get it laid out, they can configure this any way you want, and it's relatively easy to fix. I mean, if you decide that yes, you want this configuration or that configuration, it'll be quick. Now the hump, this hump here, this hump mold that forms this shape, that's all contingent on how big the bell crank. This is made for a 4-inch bell crank. So in effect, you could have a mold with different humps on it, or molded different ways. So you could have 3.5, 3 3/4, 4, 4 1/4. You could have all different sizes, whether you need them or not. That remains to be seen. So I spent a little time on this. Basically, it was just a crude way of grinding it down. I ground it down on a belt sander, and what I did, I put it up on the little 90-degree thing from the belt sander, and I angled it, and I just worked it back and forth till I ground that edge on it. Once I ground the edge on it, then I used 320 and sanded it. Skipped a lot of grits, and then I hit it with 1000. And then I used a little of this. This works out really good on aluminum. Matter of fact, no, this isn't sponsored. I bought this. They got aluminum paste, gold and silver, plastic, you know, they got all these different grits, but this stuff works really well. If you get an aluminum mold and it sort of gets gritty and you're having trouble, you want to shine it back up, this stuff is good. So you can tell how fast it's working by the color of it. So when I got done sanding it, you can see how quickly the gray shows up. And you can feel it cut, so when you rub it, you can feel the grit, and the more you rub it, the finer it gets, and the less coarse it breaks down. And then it's pretty much pure black. And then you flip it. And you can do the same. There's semi-chrome. I mean, I've seen a lot of different metal polishes, but this stuff, I really like it. What I might experiment with, I'm not sure yet, is I'll get out there and see if I can buy some of these different formulas of this same stuff, and see if I can find something that would work really well on airplane clear coat. And then of course, once you get it all polished up, and then the next step I usually do is take a clean one and I'll hit it with just a little bit of acetone. and that sort of acetone will sort of clear some of the residue off. And then once you get it clean with acetone, you can use mold cleaner, but mold sealer and a lot of different things. Then I like to hit it with a little free coat. I buy it in a can. Free coat 700 NC. And then I'll just wipe that on there, and that will give you a really good release. Now the beauty of doing this aluminum versus a composite tool is you have to worry about it sticking, but you don't have to worry about it cross-linking. So that's all you got to do, is just get a nice even film on it. And if you're going to do a lot of it or it goes through, make sure you wear gloves. And I just let it dry. I just put the nice film on it and then let it dry. And that's all there is to that. I try to keep this separate from my painting stuff. But that's the method of the bell cranks anyway. It'll be interesting to see if this comes through. See if I can get the right properties to get the bell cranks made. If I can nail it down and I get a room temp cure with a post cure of high temp, I don't know, get it up to maybe 350 degrees, 300, and then start doing some destruction testing. And if I can get it to work with my compaction, I know it'll work with an autoclave. Will it come out? Can I get this bell crank down to 7 grams? I don't know, probably not. But especially with the button and the pins and all that. So yeah, we'll find out. So anyway, where'd my shop kitty go? I got a shop kitty that comes in here. I did a couple videos previously today. Oh, here it is. Here's my shop kitty. Shop kitty loves the lawnmower. It lays up there all the time. So I did a couple videos of this. You have to go back and watch them. I'm fighting my stream things. Got a little people come in there on their PlayStation. I got rid of them. So got that taken care of. I'll be looking for them. I'll look them up. The PlayStation kids. So what I did here off camera, I 1/8" spars, and I hollowed the end of the spar out a little bit where the bell crank goes, and the spar has some holes in it. I posted a picture on Instagram of the spar before I glued it in. So that's that. Now when I actually lay this thing up, of course this is a 1/8" balsa spar. When I actually lay this up with the wing skins in the bag, I'll probably take carbon toe and I'll cap this off and lay the toe out flat, and I'll run that toe all the way out. Just a little bit, not enough to give me a hump. I'll just lay it out so it's really smooth and flat, and I'll vacuum bag it and it'll help. So this is USA One Wing fattened up. So I'll be going back and redoing this template probably for a thicker trailing edge. Do the inset flap and the molded leading edge maybe. So when I come back, I'll probably do this thing in a vacuum bag. I already have my sheeting made up for this. I'll do the vacuum bag and then we'll core it out. I'll do one wing ahead of schedule so we're actually not waiting for the glue to dry in the bag, and then we'll core it out. We'll get a pretty good core on it. Now some of this stuff here was in storage. It was on a shelf. These wings here are the same, USA 1 fattened up. And then of course there's some stabs, SV11 and Dodger wings, and who knows what some of that stuff is. One of the things I'm sort of excited about, I've got some tooling board over here. It's roughly 60 inches by, oh I don't know, it's 2 inches thick. So let's just say 60 inches by 2 foot wide. And that's this board right here. And then this stuff here, I'm going to do a video on this. This was scrap that I acquired. The best I can tell, I'm pretty sure, it's wrench shape 3020. And back in the day, we're probably talking 20-30 years ago, wrench shape 3020 is a super high density foam. It could be used for like mold bucks. And this was in a bigger block. I basically cut this block down into sheets that are manageable. I've got 2, 2.5, 3, 4, 4.5, and then I got more blocks. The beauty of this foam is the crush resistance is unbelievable. Wrench shape 3020, you know, the compression it would take was a lot. It's not like white foam or blue foam. So it's a real fine grain. It sands and it works like you think you're doing 7 or 8 pound balsa wood. That's the way it sands, but it's super stable. It doesn't move, it doesn't warp, it doesn't absorb moisture. I think it's a urethane foam board. I'm not positive. But anyway, once you carve this and sand it, the beauty of it is you can take automotive primer that's a lacquer base and you can spray it, brush it, or whatever, and it won't attack the foam. So I've done a little test on it. I've taken straight acetone and I've wetted it out with acetone and it doesn't bother it. I've taken lacquer, dope, and all the different things we'd use, and it doesn't bother it. So that's the beauty of this. It'll also take polyester body filler. Blue board foam, you can sort of get away with a quick coat of Bondo, but it's pretty iffy if it sits in there and doesn't kick quick enough. So this will be fun. What I'd like to do is start making some fuselages out of this stuff, and then making molds, and then of course the molds would be full-size stunners. So over here with the pods are just one of these things where it's a test bed for ultimately control line stunt wing. So I'm going to wrap it up with this one little tidbit here. It's sort of a funny story. So Bob Hunt was talking to me about Howard Rush, I think, coming over to his shop. And Bob was all excited about his new airplane designs and all the research he's been doing. And you have to ask Bob this story, it's funny. And Howard's an engineer, right? Howard is a real life engineer. So anyway, Howard comes over and the first thing Howard notices is Bob's bricks wrapped in foam. So Bob uses these big bricks, building blocks with foam around them for weights. So I needed a camera stand. So basically this camera that I'm holding in my right hand has got like a clip on it. So I can clip the camera to this here for a high view, or I can clip it down here for a lower view. So while I'm doing filming on the bench and it's not being handheld, the camera just clips here or here. And I thought, what am I going to use for a counterweight? You know, I need something heavy, and it can't be metal because, you know, this new glass, I don't want to scratch it or bust it. So then I thought, well, the cheapest thing I can think of is go out and get a brick. So I go out there in the garden there, and I get this brick, and then I surround it with this 1 pound scrap foam. So as it's sitting on the bench, you don't have to worry about it screwing up the glass. And so I'm going to give credit to Bob Hunt for the design of the foam wrapped bricks. And this is a deluxe foam wrapped brick for a camera stand. And if you want plans for this, you're going to have to talk to Bob, because he's the one that does the foam on the bricks. So anyway, that's what I'm going to leave you with. And it's funny because sometimes you try to over-engineer something, and you try to think of something that's really special, like lead shot or weights, and it all boils down to simplicity. So that's it. That's all I got. I guess I finally made it through the whole dang stream. So right up here it says stop streaming. I'll hit that button there. Until next time, have a good night. I'll turn this thing back on, and we'll do some vacuum bagging and coring, and among other things. Thanks for stopping by, and I enjoyed doing it.